3.0.0, the decimal system. Identify decimal numbers and calculate with them. List the key qualities of decimal numbers and summarize their place values. Add, subtract, multiply, and divide decimal numbers. Convert between decimals, fractions, and percentages. Number 10 lies at the heart of the decimal system. Learning the place values of digits early in this module establishes the groundwork of the decimal system. Decimal numbers offer numerous advantages, including simpler calculations and easier fractions. Decimals. Decimal values often include a dot or period called a decimal point within the number. Digits to the decimal point's left represent whole numbers. Digits to the decimal point's right represent fractions of the number 1. In fact, decimals often go by the name of decimal fractions since they represent parts of a whole number. Even if a decimal point is not visible, assume one to the right of the ones place. For example, with the number 5,316,247, the decimal point is on the right side of the number 7. So here is the decimal point, and we've already talked about the ones, tens, hundreds, thousands, 10,000s, 100,000s. Well, now we're taking 1 and we're splitting it into 10 pieces, and each one of those 10 pieces is a tenth of a 1. So this is the tenths, and then we'll take one of those tenths and break it into 100 pieces, and those are the hundredths, and the thousandths, the 10,000ths, and the 100,000ths, and the millionths place. To read a decimal fraction aloud, say the number as it is written, then say the name of the place value for the rightmost digit. For example, 0.56 is spoken as 56 hundredths. The rightmost digit 6 is in the hundredths place. Rounding decimals. Sometimes an answer can be too precise. For example, assume tubing costs $3 or 3.76 pounds. The symbol represents the euro. The currency in the European Union per meter. If the budget specifies 800 euros for the tubing, how much tubing can be purchased? The answer is approximately 212.765957 meters. Goes on for many decimal places. However, a supplier will not sell 0.765957 meters of tubing. An answer to the nearest tenth suffices for this application. Therefore, round the number to a single digit in the decimal points right. The following steps show the process. So here, the 0.7, we're going to round it to 0.8 because the next digit is a 6. It's 5 or greater. If the digit to the right is 5 or more, round up by adding 1 to the underlined digit. If the digit is 4 or less, leave the underlined digit alone. So 212.8. 3.1.2, comparing decimals with decimals. Note, in this case, following the rounding rules causes a slight budget overrun. Here we have 800.13 euros budget. Sometimes follow their own rounding rules to avoid financial problems. Unless instructed otherwise, however, always follow the standard rounding rules. Deciding if one decimal value is larger or smaller than another one is simple. The process resembles comparing two whole numbers. Examine the following numbers: 4,214 and 4,217. Obviously, 4,217 is larger. Adding a decimal point does not change anything. 0.4214 and 0.4217, the result is the same. The number with the digits 4, 2, 1, and 7 is still larger. 3.1.3 study problems, working with decimals. For the following problems, identify the words that represent the proper way to read aloud the decimal values shown. So this is 0.4 or 4/10 B. 0.05 is 5/100ths, 5/100ths. 2.5 is 2 5/10ths, 2 5/10ths. For the following problems, identify the written numerical value of the spoken number. So 18/100ths is 0.18. The 8 is in the hundredths column, so we want to make sure it's 0.18. That's 18/100ths. If you're not sure, then just read the numbers that they have in front of you and see which one sounds right. This is 1 8/10ths. This is 18/100ths. This is 18/1000ths. And this is 18/10,000ths. So they want 18/100ths. 5 8/10ths. That's 5.8. 5 8/10ths. For the following problems, select the answer that arranges the decimals from smallest to largest. So we have four numbers here: 0.400, 0.004, 0.044, and 0.404. So the one that has the largest number after the point, which is 0.404, this is the largest number. It should be the last one in the series. The second to last is 0.400. The first in the series is this 0.004, and the next one is 0.044. So to arrange them from smallest to largest is 0.004, 0.044, 0.400, and 0.404. Okay. If you have any difficulties with these, check with your instructor, and they'll help you understand it better. Adding, subtracting, multiplying, and dividing decimals. 3.2.1, adding and subtracting decimals. When adding or subtracting decimals, always keep the decimal point aligned. To add 4.76 and 0.834, line up the problem as shown. Line up your decimal points, and then add hundreds or thousands to thousands, hundreds to hundreds, tens to tens. So 0 plus 4 is 4, 6 plus 3 is 9, 7 plus 8 is 15, write the 5, carry the 1, and then 4 and 1 is 5. And then we put the decimal point in the same place, so we end up with 5.594. Did you know dots and commas? In the United States, the dot or period acts as the decimal point. Commas separate every 3 digits of the whole number. For example, 14,203,897. But many European, African, and South American countries do the opposite. A comma acts as the decimal point, and the dot separates every 3 whole number digits. So the numbers 845,302.125 in the United States and 845,302,125 in Europe are the same. Multiplying decimals. When we're multiplying decimals, we can ignore the decimal point. Write the numbers in digits. So 4.5 times 7, write the 7 below the 5. Multiply the two numbers as if you're multiplying 45 times 7. 7 times 5 is 35. Write the 5, carry the 3. 7 times 4 is 28, plus 3 is 31. 315. Now, count the decimal places. There's 0.5, so there's one decimal place. We're going to put our decimal point between the 1 and the 5. 31.5. To place the decimal point, count the number of digits to the right of the decimal point of both numbers being multiplied. In this this example, only 4.5 has a decimal point. There's just one digit to the right. Place the answer's decimal point by counting over the same number of digits from the right, 31.5. If there are more digits to the right of the decimal point than there are in the answer, add extra zeros to the left of the digits. So here they're multiplying these two numbers. I'm not going to go through the multiplication, but they ended up with this number 11154, and you count 1, 2, 3, 4, 5, 6 decimal places. So you move 1, 2, 3, 4, 5. When you move the sixth decimal place, you have to put a 0 to the right of the decimal point to get the correct answer. Three point 2.3, dividing with decimals. Dividing decimal numbers can take on one of three forms. Those with a decimal point in the number being divided, the dividend, 22 goes into 44.5. Those with a decimal point in the number being divided by the divisor, 0.22 divided into 4,450. Those with decimal points in both numbers, 0.22 divided into 44.5. The following examples demonstrate each type. Step 1, place the answer's decimal point directly above the dividends. So if you have 22 going into 44.5, the decimal point goes directly above the decimal point above the division bar. And then divide as usual. 22 goes into 44 twice, makes 44. You have a remainder of 0.5. The answer is 2 with a remainder of 0.5. Note that the quotient's decimal point aligns with the dividend's decimal point. This alignment is critical. In example number 2, dividing two numbers with the following, there's a decimal point in the dividend. So move the divisor's decimal point all the way to the right. Count the number of places that it moves. 2. So 1, 2. 0.22 becomes 22. Next, move the dividend's decimal point to the right the same number of places. If you moved the divisor's decimal point by 2, move the dividend's decimal point by 2. Since the dividend is a whole number, add extra zeros. Place the answer's decimal point directly above the dividends. Divide as usual. So here we have 4,450 divided by 0.22. We move that decimal point 2 places, add extra zeros, and then the decimal point goes right above the dividends decimal point. And then you divide as usual. Scientific notation. All right. I don't want to confuse you, but let's talk about scientific notation. Scientific notation, sometimes called exponential notation, is a system that manages very large or very small decimal numbers. Numbers in this form have two parts, the base and the exponent. The base is a regular whole number or a decimal number. The exponent represents the number of times to multiply by 10. So 10 squared equals 10 times 10. 10 to the third equals 1,000. 10 to the fourth equals 10,000. That number is how many times you've multiplied 10 by itself. A negative exponent represents the number of times to multiply by 1/10. So 10 to the negative 2 is actually 1/100th. So here's decimal notation. 1 equals 1 times 10 to the 0th power. Negative 50 is negative 5 times 10 to the first power. Here's 7,530,000,000 is actually 7.53 times 10 to the 9th power. You're moving this decimal point 9 places. 1, 2, 3, 4, 5, 6, 7, 8, 9. In scientific notation, you always want to have just one digit whole number plus any decimals after that decimal point times 10 to some power of 10. That will move the decimal point the right number of places. Here, we're moving 1, 2, 3, 4, 5, 6, 7, 8, 9 decimals to the right. So it's a negative exponent. So it's 8.2 times 10 to the negative ninth. Let's see here. Divide type 3 numbers using the following steps. So if you have a dividend of 44.5 and a divisor of 0.22, you have to move the decimal point 2 places to the right. Move the dividend's decimal point the same number of places to the right, 2. Add extra zeros if required. So 0.22 becomes 22, and 44.5 becomes 4,450. Then you put the decimal point above the dividend's decimal point, and you divide as usual. 3.2.4, using the calculator to add, subtract, multiply, and divide decimals. Doing decimal math with a calculator resembles calculating with whole numbers. Follow these steps using the problem 45.6 plus 5.7 as an example. So turn the calculator on, press 4, 5, decimal point 6. The numbers 45.6 appears. Press the plus key, then the 45.6 should stay on the display. Press 5, decimal point 7. The number 5.7 appears. Press the equals key. The answer should appear. Press the on or clear key to clear the calculator fully. The CE key clears the most recent entry only. A 0 should appear on the calculator. So repeat the previous steps, but select a different operation, minus, times, or divide. The sequence to perform all 4 operations. So let me see if you can see my calculator. What they're saying here is we can do 45.6 plus 5.7, and then we'll hit the equals 51.3. Clear. Now I'm going to do 45.6 minus 5.7 equals. Oh, yeah. What did it do to me? Let me do this again. I think it hit it twice. Sorry. I'm having trouble with my mouse. 45.7 or 0.6 minus 5.7 equals 39.9. 45.6 times 5.7 equals 259.92. 45.6 divided by 5.7 equals 8. So that's how you use a calculator. We'll talk further about that when we're in class. But next step, press whichever operation key the problem specifies. Add, subtract, multiply, divide. 3.2.5, study problems, decimals. Without using a calculator, find the answers to these addition and subtraction problems. Be sure to keep the decimal points aligned. Okay. 2.50 plus 4.20 plus 5.00. So I'm going to try to do these for you. Oh, where did we go here? What happened to my... Yeah, there we go. Okay, so this number 1 is 2.50 plus 4.25, 4.20 plus 5.00. They want us to add those. So the zeros are just 0. 5 plus 2 is 7. Put your decimal point. 4 plus 5 is 9, and 2 is 11. So we end up with 11.70. The next one is 1.82 plus 3.41 plus 5.25. So 5 plus 1 is 6, and 2 is 8. That's not right. Yeah, it is. Sorry. 8 plus 2 is 10, and 4 is 14. Write the 4. Carry the 1. 1 plus 1 is 2, plus 3 is 5, plus 5 is 10. So we'll write the 10, and we'll put our decimal point underneath, 10.48. We have 6.43 plus 86.4. I'm going to put the 86 on top. I don't know why. I'm just going to. 86.4. And I'm going to put a 0 as a placeholder where we don't have 1 in 86.4. And 0 plus 3 is 3, and 4 plus 4 is 8. We're going to draw our decimal point. 6 plus 6 is 12. We'll write the 2 and carry the 1. 8 plus 1 is 9. 92.83. Now, it says, number 4, the combined thickness of a piece of sheet metal is 0.078 centimeters thick, and a piece of band iron is 0.25 centimeters thick. They want to know the combined total. So 0.25 centimeters and then the sheet metal 0.078. Now I'm going to draw a 0 as a placeholder above the 8, and 8 and 0 is 8, and 5 and 7 is 12. We'll write the 2 and carry the 1. 2 plus 1 is 3. There's our decimal point, so it's 0.328 centimeters. B. It says, yesterday a lumberyard contained 6.7 tons of wood. Since then, 2.3 tons were removed. How many tons of wood remain? So 6.7 tons minus 2.3 tons. How many tons remain? 7 minus 3 is 4. Draw your decimal point. 6 minus 2 is 4. 4.4 tons remain. B. Use the following information to answer questions 6 and 7. A machinist mills a part. The starting thickness is 6.18 inches. The machinist makes 3 cuts, 3/10 of an inch each. How many inches of material have been removed at this point? So we're making 3 cuts, 3/10 of an inch, 0.3 inches. So how much material has been removed? 3 times 3 is 9. And then we count how many decimal places we have. 1. So we'll put the decimal point to the left of the 9. Our answer is 0.9 inches have been removed. C. 0.9 inches of material has been removed. So we started with a piece that was 6.18 inches thick. Now they're saying to us on number 7, the remaining part thickness is how many inches? And we removed 0.9. inches of material. So we'll write 0.9, and I'll put a placeholder there. 8 minus 0 is 8. 1 minus 9, well, I can't subtract 9 from 1. So I'm going to borrow 1 from my 6, from my ones column. I'm going to make that 5, and I'll borrow that 1 and make this 11. 11 minus 9 is 2. I'll put my decimal point, and then 5 minus 0 is 5. So the remaining material is 5.28 inches. 5.28 inches. Okay. Ceramic tile weighs 4.75 pounds per square foot. Therefore, 128 square feet of ceramic tile weighs how much? Okay. So they're saying that 1 square foot weighs 4.75 pounds. And there's 128 square feet. 128 square feet. You could put either one on the top. It doesn't matter. I'm just going to put this one here. So 8 times 5 is 40. And 8 times 7 is 56 plus 4 is 60. And 8 times 4 is 32 plus 6 is 38. And then we'll bring down our 0. 2 times 5 is 10. I'm going to put my 1 up here. 2 times 7 is 14, and 1 is 15. I'll write the 5 and carry the 1. 2 times 4 is 8, and 1 is 9. Now I'm going to put 2 placeholders because the 1 is in the hundredths column, and 4.75, I'm just going to go ahead. 1 times 5 is 5. 1 times 7 is 7. 1 times 4 is 4. Now I'll add these up in columns. 0, 0, 5 and 5 is 10, and 8 is 18. 9 and 1 is 10, and 7 and 3 is 10. That's 20. I'll do that again for you because I may have confused you. And 4 plus 2 is 6. So here's 0, 0, 0, 0, 0, 0. 8 and 5 is 13, plus 5 is 18. I'll write the 8, carry the 1. 1 plus 3 is 4, plus 9 is 13, plus 7 is 20. I'll write the 0 and carry the 2. And 2 plus 4 is 6. Now, I have 2 decimal places. 1, 2. So I'm going to put my decimal right there. 1, 2, 608 pounds. 128 square feet of ceramic tile weighs 608 pounds. B. Okay. Without using a calculator, find the answers to the following division problems. Round your answers to the nearest hundredth. Okay. They're telling us to round our answer to the nearest hundredth. So let's take a look at these problems, and then we'll round our answers. 45.36 divided by 18. So I think 18 times 3 is, nope, that's too much. That's 54. Okay, so we're going to put it in 2 times, 36. 18 times 2 is 36. And then we'll subtract 15 minus 6 is 9. And 3 minus 3 is 0. I borrowed 1. I didn't show you, but I borrowed 1 from the 4 in order to make this 15 minus 6 is 9. And then 3 minus 3 is 0. So I have 9. So now bring down the next digit, the 3, I'll say, how many times does 18 go into 93? 4, 5. It'll go in 5 times. That's 50, 90. Yeah, I believe that it'll go in 5 times. 5 times 8 is 40. We'll write the 0 and carry the 4. 5 times 1 is 5 plus 4 is 9. So that's 90, and then we'll subtract 3 minus 0 is 3. So we're going to bring down the next digit. We'll bring down the 6. Oh, and what I did not do is I didn't put this decimal point in. I should have done that at the very beginning. This decimal point goes right above it, above the division bar. So 18 goes into 36 twice. 18 times 2 is indeed 36. So we have a remainder of 0. We have no remainder. So the answer to the number 9 is 2.52. 10 is 4.536 divided by 18. So again, 18 times 2 is 36. I'm going to borrow 1 from the 4. Say 15 minus 6 is 9. And 3 minus 3 is 0. So bring down the 3. Write 93. And 18 goes into 93 5 times. And 18 times 5 is 90. 3 minus 0 is 3. And then we're going to bring down the 6. And 18 times 2 equals 36. Now here's my decimal point. So we're going to put our decimal point here. Our answer is 0.252. But what did they ask us to do? They said round your answer to the nearest hundredth. So this answer becomes 0.25. We're going to round that to the nearest hundredth. 0.25. Now, finally, one last time, we have 0.4536 divided by 18. So I'm going to put this decimal point here, and 18 does not go into 4, so we'll write a 0. 18 goes into 45 twice. It's 36. And again, we have to borrow from the 4 to make this 15 minus 6 is 9. And we'll bring down the 3. And 18 times 5 equals 90. And 3 minus 0 equals 3. Let's bring down the 6. 18 times 2 equals 36. With a remainder of 0. Now, again, our answer is 0.0252. They want us to round to the nearest hundredth, so we're going to round at 0.03. We're going to round up because the next number is 5 or greater, so we're going to make this 0.03. And that's our answer to number 10. 12 is 25 divided into 10.20. So 25 divided into 10.20. And 25 does not go into 10, so we'll write a 0. There's my decimal point. 25 goes into 102 4 times. 25 times 4 is 100. So we'll subtract and we'll get 2, 0, 0. And we're not going to worry about the decimal point anymore until we get to our answer. I'm going to bring down this last digit, which is a 0. 25 does not go into 20, so we'll write a 0. We're going to put a phantom 0 here, and we're going to bring down the phantom 0. And we'll put the 0 here, and 25 goes into 200 8 times. 8 times 5 is 40, and 8 times 2 is 16, plus 4 is 20. So there's no remainder, and our answer is 0.408, and they want us to round to the nearest hundredth. So we're going to do 0.41. Because the 8 is 5 or larger, we're going to round up to 0.41. Okay. 13 is 6 divided into 31.2. Oops, I'm sorry. I'm talking while I'm walking here. 31.2. I'm going to put the decimal point above it. 6 times 5 is 30, so I'm going to put the 5 here. Bring down the 30, and then 1 minus 0 is 1. I'm going to bring down my 2. Oh, wrong color, sorry. Bring down my 2. 6 times 2 is 12, so I'll put my 2 here, which is 12, with a remainder of 0. Now, my answer is 5.2, but they want us to round to the nearest hundredth, so we're going to just put a 0 and say 5.20, and that's rounded to the nearest hundredth. Okay. Without using a calculator, find the answers to the following division problems. Round your answers to the nearest hundredth. Okay. Without using a calculator. All right, so 282. Divided by 14.1. Well, I'm going to write 141. I'm going to move my decimal point one place to the right. So here I'm going to move my decimal point one place to the right and put this 0 as a placeholder. So it's 141 divided into 2,820 instead of 14.1 divided into 282. So 141 goes in twice, makes it 282. Subtract, we get 0. Now, be careful. You want to make sure you put your decimal point straight above the decimal point in your dividend, and then you bring down the next digit, which, of course, it's 0. So 141 doesn't go into 0. We're going to write a 0. Our answer is 20. Okay, and let's just see. Oops, that's not what I meant. Sorry. Where's my calculator? There. Come on. Give me a break. There. So we're going to check our math here. We said 282 divided by 14.1 equals 20. So we did right. We did exactly right by putting that phantom zero because we had to move the decimal point when we moved this decimal point. So I don't have a problem with you using a calculator to check your work. After you've done it, use a calculator to check your work and see if you're right. I don't have a problem with that at all. So this is 694 divided by 3.2. Again, I'm going to write the 3 and the 2. I'm going to move my decimal point one place to the right and put a placeholder there. So 32 times 2 equals 64. 9 minus 4 equals 5. And then I'm going to bring down the 4, which 32 will only go into 54 once. It's 32. And then we'll subtract 4 minus 2 is 2. And 5 minus 3 is 2. And now we'll bring down our last digit to 0. And we'll say 32 goes into 220 6 times. I'm going to try 6. I don't know if it'll go in 6. I'm going to try 6. 6 times 2 is 12. 6 times 3 is 18, and 1 is 19. Maybe it would have gone in 7. I don't know. No, it wouldn't have gone in 7. All right, so here I'm going to borrow 1 from the 2 to make this 10 minus 2 equals 8. And 11 minus, okay, so I have to borrow 1 from this 2 to make this 11 minus 9 equals 2. And then 1 minus 1 is 0. So it's remainder 28. I have 216 with a remainder of 28. But they said round your answer to the nearest hundredth. So we're going to put 0 as a placeholder. And we're going to bring that 0 down. There. And we'll put it here. We'll say 32 goes into 280. How many times? I'm going to try 8. I'm going to try 8. I don't know if it'll go, but I'm going to try. 8 times 2 equals 16. I'm going to write the 6 and carry the 1. 8 times 3 is 24. And 1 is 25. I think we picked well. So here, 0 minus, I'm sorry, not 0, 10. I have to borrow 1 from the 8, make this 7. 10 minus 6 equals 4. And 7 minus 5 equals 2. And 2 minus 2 equals 0. So let me scroll back up. I'm going to have another phantom 0 that I'm going to bring down. There. And now 32 goes into 240. Let's see here. I'm going to try 7. Let me try 7 times. I'm going to try 7 times. Let's see if I can make it work 7. 7 times 2 is 14. Carry the 1. 7 times 3 is 21, plus 1 is 22. Yeah, that works, 22. All right. So here, 0 minus, I'm sorry, not 0, 10. I'm going to borrow 1 from my 4, make it a 3. Make this 0 a 10. 10 minus 4 equals 6. And 3 minus 2 equals 1. And 2 minus 2 equals 0, so we have 16. So now I need to know if I'm rounding up or down. They want us to round to the nearest hundredth. So I'm going to write one last phantom 0, and I'm going to bring this phantom 0 all the way down here. And I'll see how many times 32 goes into 160. 4. I'm going to try 5 times. I'm going to try 5. Let's see if it works for 5. 8, 7, 5. Here, 5 times 2 equals 10. Carry the 1. 5 times 3 is 15. And 1 is 16. So it's 160. And indeed, that's what we have, 160. So there's a remainder of 0. So this is the right answer, 216.875. But because the 5 is greater than, or 5 or above, our answer rounded to the nearest hundredth is 216.88. There's our answer, 216.88. Okay. Okay. I'm gonna stop here. Any of these others, feel free to try them on your own. If you have any questions, ask your instructor. If you want to ask me, you can put it in the chat or in the comment section, and I will try to get you an answer. I'll try to answer any questions that you put in. Okay. Uh, 3.3.0. Converting decimals, fractions, and percentages. Let's see what they have to say. I'm going to make this large now. Sometimes craft professionals must convert one number form into another to make it work easier. Some numbers may appear as decimals, some as percentages, and others as fractions. Decimals, percentages, and fractions are all different ways of expressing the same thing. The decimal 0.25 is the percentage 25%, and the fraction 1/4 all represent the same quantity. Each form can change into one of the others. Converting decimals to percentages and percentages to decimals. To understand percentage, think of a whole number divided into 100 parts. A $1 bill is a good example since it equals 100 equal parts, pennies. Each penny represents 1% of a dollar. Any part of a whole can be expressed as a percentage. Figure 5 shows a good craft example. In fact, to be specific, per means divided by, and centenal or centage, a century is 100 years. A centenarian is 100 years old. So this is saying divided by 100. So divided by 100. So if you said 75%, it's 75 of 100. 50% is 50 of 100. That's what percent means, of 100. So it says the tank holds 100 gallons. At present, it contains 50 gallons. To what percentage is the tank filled? Well, it's filled to 50/100ths. The correct answer is 50%. Percentage reflects a quantity based on there being 100 parts of something. How many gallons out of 100 does the tank contain? It contains 50 out of 100, or 50%. Percentages are an easy way to express parts of a whole. Decimals and fractions also express parts of a whole. The tank in figure 5 is 50% full. Expressed as a fraction, it is 1/2 full. The decimal equivalent is 0.5 full. It's just like your gas gauge in your car. It goes full, 3/4, 1/2, 1/4, empty. So percentages can include decimals too. Adding a gallon of liquid to the tank increases it to 50.5% full. Okay. Follow these steps to convert to a percentage. Multiply the decimal value by 100. Tip: to multiply by 100, simply move the number's decimal point 2 places to the right. So if you have 0.12 times 100, it equals 12. Just move the decimal place 2 places to the right. Add a percent sign. So 0.12 is 12%. Mixture must contain 10 to 15% of the concentrate. Since there's a 12% of a gallon available, there's enough concentrate to make 1 gallon of working solution. Converting percentages to decimals is simple too. Suppose a 1 pound mixture must contain 22% of a certain chemical by weight. A digital scale which reads in decimal values weighs the ingredients. To determine the correct amount of the chemical in chemical form, convert the percentage, 22%, to a decimal by following these steps. Drop the percent sign and move the decimal point 2 places to the left. To divide by 100, simply move the number's decimal point 2 places to the left. So 22% is 0.22. Make the mixture by weight out of 0.22 pounds of the chemical, add it to 0.78 pounds of the other ingredient, giving a total of 1 pound. Okay. These are shims, that's 0.015 inches, or whatever they're using. Converting fractions to decimals. Changing a fraction into a decimal requires nothing more than division. Remember, a fraction is already a kind of division problem. Changing a fraction into a decimal value requires dividing the numerator by the denominator. So here, 3/4 of a liter into decimal value. So you divide 3 divided by 4, and it should come out to be 0.75, which is 3/4. 3.3.3, converting decimals to fractions. Converting a decimal to a fraction is also simple. Remember that both decimals and fractions express the same thing in different ways. Saying a decimal value aloud sounds like a fraction. Writing the spoken form automatically translates it. For example, drill bits come in fractional sizes, decimal sizes, and even sets identified by special codes. A carpenter must drill a 0.125-inch hole. However, the available drill bits have fractional size markings on them. One of those sizes might be equivalent to 0.125 inches. To find out, the carpenter must follow these steps to convert the decimal to a fraction. Say the decimal value aloud. 0.125 is 125 thousandths. Write the words down as a fraction. 0.125 written as a fraction is 125 thousandths. Reduce the fraction to its lowest term. So we end up with dividing by 125 is 1, and 1,000 divided by 125 is 8. So 0.125 is a 1/8 inch drill bit. Converting inches to decimal equivalents in feet. Unlike the United States, most other countries use the metric system of measurement. Metric system perfectly matches the decimal system since both rely on units of 10. However, for those working with the inch-pound system, measurements may require conversion to decimal. For example, what decimal part of a foot does 3 inches represent? 1/4. First, express the inches as a fraction with 12 as the denominator. Remember, 1 inch equals 1/12. The fraction for 3 inches is 3/12. Reducing the fraction gives 1/4. Convert this decimal by dividing 4 into 1. So 4 goes into 1 0.25 times. So 3 inches equals 0.25 feet. practical math applications. When contractors calculate the expenses for building a house, they must pay close attention to the percentages they choose for various factors. Of course, they want to maximize profit as well. For example, if a contractor is building a house that will sell for $175,000, what will the profit be with the following percentage breakdown? Overhead is 27%, materials are 35%, labor is 24%. Well, we'll add those three together. 7 and 5 is 12, and 4 is 16. 3, 6, 8, that's 86, gives you 14% left for profit. So 14% times $175,000 gives you $24,500 profit. Okay, 3.3.5 study problems converting different values. Convert these decimals to percentages. Okay, these are easy. 60.62, we'll just move the decimal point 2 places to the right and add the percent sign. That's 62%. 0.475, same thing, we're going to say 47.5%. And 0.7 is 70%. Move the decimal place 2 places to the right and add the percent sign. Convert these percentages to decimals. All right, well, 72%, we're going to drop the percent sign and move the decimal 2 places to the left, so it's 0.72. 12.5%, we're going to move the decimal 2 places to the left and drop the percent, it's 0.125. That's the decimal equivalent of 12.5%. And remember before that 12.5% or 0.125 is actually 1/8. Without using a calculator, convert the following fractions to their decimal equivalents. All right. I'm going to leave you to do these. Divide 1 divided by 4, 3 divided by 4, 1 divided by 8, 5 divided by 16, and 20 divided by 64. And if you have any problems with those, check with your instructor, or you can write it in the chat and I'll try to get you an answer. All right, very good.